Maths are for me, maths are for you. That. Look how hard me I work, oh God. Now feel maths me work so hard. Confident out there now, one straight A's now. Maths in my world, my world.
Hello again, students. Kenroy here, and today we are talking about equations. We'll be focusing on a useful method to solving equations. If you haven't guessed it by now, then it's the balancing method. So as we look at our method, we must first consider the main points of this session, or objectives. Let us first look back at the definition of an equation. Then, the meaning of that little sign that makes an expression an equation. We will then explore the idea of balance, which we will then apply to equation solving. Finally, we will solve some equations by using the balancing method. So, what is an equation? Well, in the previous lesson, we would have explored expressions and equations. We said that an equation is a mathematical sentence that shows equality. Some examples are 6 added to 7 is equal to 13. 8 multiply 9 is equal to 72. 45 subtract 6 is equal to 39. And 48 divided by 8 is equal to 6. Do you now recall what an equation is? Did you say yes? Awesome. Now let us look closer at the sign that makes an equation a sentence and not just a statement. Yes, the equal sign. The equal sign, well, it looks like this. To understand an equation as a sentence, it helps to read the sign by calling it is equal to. For example, 6 added to 7 is equal to 13. Here, the sign shows us that one side is the other, which also suggests that they are equal. The sides are balanced. What do you think of balance? Is there anything that comes to your mind? Well, something I can think of is a seesaw. Do you remember playing on one of these? What was the fun about? Yes, you guessed it, balance. It was ensuring that the person on the other side could hoist you up far enough, and then you could do the same for them. So a seesaw is basically a game of balance. If you and a friend have the same weight as being depicted in the photo, what would happen if a weight was added on your side? Would it still be balanced then? How could you make it balanced again? Let us see this in action. What would be the result of placing these counters on the board balance? Did you say it would tilt to the right? Yes. There are more counters on the right, so that side would be heavier. The number of counters are greater on that side. What would we need to do in order to balance our situation? Did you say add 2 to the left? Let us see. Yes, we would need to add 2 to the left side. Now we would have balance. The number of counters on the left side and the right side are the same. Using this same diagram, I want to sustain my balance. If I added some more counters on the left, what must I do to keep my diagram balanced? Did you say add the same number of counters to the right side? Yes, I will need to add the same number of counters to the other side, the right side, in order to keep it balanced. Similarly, if I removed counters from one side, say the left, I would need to do the same to maintain balance. I would need to remove the same number of counters from the right. This is the idea of balance that is applied to equations. Consider the equation. 2 added to 3 is equal to 5. We can view this on a counter level to illustrate this method of balancing, that is. 2 counters added to 3 counters is equal to 5 counters in total. Now, what if I removed 3 counters from the left? Think about what I have to do so that the sentence remains balanced. As it is now, we can see that 2 is not the same as 5. Did you say remove 3 counters from the right? Yes, brilliant. Now we have balance. 2 is equal to 2. Using the same equation but with a slight modification, instead of 2, we will use the variable x. So now our equation says x added to 3 is equal to 5. Remember, x is for representative purposes, and as such, we are not able to quantify it just yet. Using our counters to represent our equation, we can then see it as this. Now, how can we go about solving by implementing our balancing strategy? Did you say remove 3 counters? Yes, it is possible to remove 3 known things, which would then leave us with the mystery number and something else. But what? What will x be if I remove 3 known counters? Well, as we can see, if we remove 3 known counters from the left, then to maintain balance, we must also remove 3 counters from the right. What is the statement saying that we are seeing? Yes, x is equal to 2 counters, or x is 2 counters. This is how we use balance to solve an equation. In this case, we ensured that we subtracted 3 counters from both sides. Let us now look at this method with another operation. What do you think we would do if it was subtraction? In this example, we are saying that some number represented by x, if we take 6 from it, the difference will be 39. How do you think we would go about solving this problem? In a way specifically that you can understand it. Well, in thinking about this problem, we see that if we had not taken 6 from that number, we would have the exact amount that x is representing. True? So true. So let us replace the 6 that is being taken from x. In other words, let us add 6 to our expression. Did we see that? Have we changed our equation in any way? Did you say yes? We did indeed. Adding 6 to only one side leaves our equation unbalanced. So, to counter or to create balance, we need to add 6 to the other side as well. Removing 6 and adding 6 results in no change or 0. And now we see our solution. We added back 6 to the value of x, which turns out to be 45. By balancing, repeating any action performed on a particular side of the equation, we are now able to arrive at our solution. Here, to maintain balance, we added 6 to both sides of our equation. Does it work with any other arithmetic operator? What about with worded problems, similar to those explored in previous lessons? Well, let us see. The first form cohort at Mount Bless High School has 72 students. There are 8 classes with the same number of students in each class. What is the number of students in a class? What is the first thing we will need to do? Do you recall from our previous lessons? Great. And yes, we need to identify our quantities and write out how they are related. Yes, write it as a mathematical sentence, an equation. So, There are 8 classes with a total of 72 students in all. That is, 8 groups of an unknown number of students is 72. I will allow you to write an equation to match our situation. Ready? Okay. Did you say 8 multiplied by an unknown quantity is 72? Brilliant. The letter you use to represent your unknown quantity does not matter. In my case, I use the letter C. My equation is 8C is equal to 72. In English, that is saying that 8 classes are 72 students. Now, how do we solve this equation? Well, when you think about the problem, we can see that we are trying to count the students all at once. What if we separated and just counted one group? Would this work? Did you say yes? Well, let us see. Since there are 8 classes, to count one group, we would need to divide our numbers into 8 groups. That is, we would divide our expression 8 multiplied by C by 8. Are we done? Or does that affect the balance of our equation? Yes, it will affect it. So to maintain that balance, I would also have to divide that 72 by 8 as well. Now we see that a class, or just C in mind, would give a total of 9 students. That is to say, there are 9 students in a class. Did you get the number of students, the same number of students that is? Awesome. Take note that in this case, to keep our equation balanced, we divided both sides by 8. Let us look at another example. Here, we are concerned with sharing fruits. Pause the video and first attempt to write the mathematics sentence for this scenario. Ready? Okay. Did you say the variable you chose, say y, divided by 8 is 6? Brilliant. Note also that I wrote both representations of this question, either of which is fine. Now, take another pause on the video and work on your solution. Ready? Okay. The number of fruits in the basket were shared 8 times to give equal shares of 6 fruits per person. We are interested in the total number that was shared in the basket, or the total number that was in the basket prior to sharing. So instead of sharing, let us regroup the fruits and do a general count. That is, we will be thinking about 8 groups. 8 groups of y divided by 8. It looks like this. Yes, it seems you remember that we must maintain balance by doing the same action on either side or on the other side of the equation. So, did you get 48 fruits when you were done with your calculations? Awesome. The basket originally had 48 fruits. To maintain balance in this case, we multiplied by 8 on both sides. Did you notice anything about this method of balancing equations? Take a second to record any of these observations. Did you notice what happened each time when one of the arithmetic signs were being used? What did we have to do when the problem was about addition? Well, to solve, we had to subtract from both sides. Did you guess that? Great. What did we have to do when the problem was about subtraction? Well, to solve, we had to perform addition on both sides. What did we have to do when the problem was about multiplying? Well, to solve, we had to perform division on both sides. And what did we have to do when the problem was about dividing? Well, to solve the question, we had to perform multiplication on both sides. Are you seeing a pattern? Did you say opposite operations? Yes. In solving our equations, not only did we have to perform the same arithmetic action on both sides for balancing methods or for balancing purposes, but these actions were in opposite to what the problem was originally focused on. In a sense, we had to undo the equations to reveal the unknown quantity, all while performing the same actions on both sides. In summary, we could say the equal sign in an equation reminds us that both sides are balanced. Because equations are balanced and should remain that way, when we are solving, any operation that is done on one side is automatically done on the other. Lastly, we arrive at the solution to an equation by performing opposite arithmetic operations. So students, until next time, you have to remember to keep practicing.
Maths are for me, maths are for you, that.